In the first part of Chapter 2, we looked at ways of displaying data sets. In the second half, we look at ways of summarizing the data sets with a single number. In Section 2-3, we start off with what are called measures of the center. In other words, we're going to have a single value that looks at the center of the data set. We have the mean, which is basically the average, median, which is the middle value in the data set if it's ordered from smaller to larger values, the mode, which is the most common value in the data set, and then mid-range, which is basically halfway between the minimum and maximum data values. And so 4 different ways to measure the middle, to measure the center of our data set. So again, back to mean, and if it's for a sample, we use x bar. If it's for a population, we use mu. Looks kind of like a U. And basically, the little E-like figure there, that's sum. So we're just going to sum up all the x's, all the data values, and then divide by the total, an average. Median, the key is that we have to go in an ordered set from the smallest to the largest. Now, if there's an odd number of data values, then the median is the exact middle value. So, for example, if there were 7 total values in your data set, the 4th one would be the middle because there would be 3 values in the data set that were less than that and 3 values that would be greater than that. However, if there is an even number of data values, the median is the average or the mean of the 2 data values that would be in the middle. And we'll go over some examples of this in a moment. Again, the mode is the most common data occurrence, so it's the one with the greatest frequency if you were looking at a frequency distribution. If there are 2 data values with the same highest frequency, then we would say the data set is bimodal. It can also be multimodal if there are more than 2 such values. And it can have no mode at all if every single data value in the data set is different, or they're all the same, in which case then it would be uniform. And then in an equation form for mid-range, minimum value plus maximum value divided by 2. Now, if we have a frequency distribution instead of the actual values and we want to find the mean, we use this equation. And again, the little E-like figure, that's the sigma. That stands for sum. The F here is the frequency of whichever class you're looking at. And in this case, the X is not the data value, but is the midpoint of that class. And so what we have here is frequency times its midpoint, and then we add up all the different classes, and then we divide the whole thing by the sum of all the frequencies. So, 4 ways of measuring the center. Now, to just give you a feel for how some of these are related for various distributions, we can look at, first off, a symmetric distribution, something that's kind of normal-like. And notice that the mean, the median, the mode are all in the middle. In this case, they all look like they're about at 8. And they're all the same because it's symmetric. Next, we have a uniform distribution. They all have a frequency of 20. Note in this case that there's no mode because since all of them have the same maximum frequency, nothing stands out. And again, since it's all uniform, we have the middle 8 as being the mean and the median. The last 2 distributions are what we call skewed distributions, in which the highest, the peak, has been shifted. And in the first case, where we have skewed left, notice that there are a lot more data values to the left. If it's skewed right, there are a lot more data values to the right of the peak. It's not in the middle like it was before. And note, compared to our symmetric one, in which all the pieces lined up together, the mean, the median, and the mode, here they're shifted. So the mean in a skewed left distribution is the lowest, then the median, then the mode, whereas when you look at a skewed right, they switch. Now it's the mode that's the smallest value, then the median, and then the mean. It should be pointed out, of course, that in none of these cases for mean and median and mid-range do they have to actually be one of the data values. All right, so let's look at some examples here. So here we have a small data set. Graded averages 76, 72, 88, 60, 72, 68, and 94, and we want to find the mean, median, mode, mid-range of these. So first off, mean, add them all up, divide by the total. There are 7 different values. I've added them all together. I end up with 530. 530 divided by the 7 gives me a mean of 75.7. So again, the mean does not actually have to be any of the values in your data set. Mid-range, on the other hand, the lowest was 60, the highest was 94. Add the 2, divide by 2, and we have the mid-range, 77. And again, none of these have to actually match. Here I've reordered them from the smallest to the largest, so 60, 68, 72, 72, 76, 88, 94. And then, since there are 7 of them, the middle one will be my median. In this case, it's the 72. Now, you might say, well, wait a minute, there's another 72 right there, and that's okay. This is still the middle value, and there are 3 on this side, and there are 3 on that side, so that's what makes that 72 the median. And then, since there are 2 72s, and nobody else is more than once, the mode is 72. All right, let's look at a second example. This time we have 150, 300, 350, 232, 360, 1231, 810, and 229. Please note that these are actually thousands of dollars, so the 150 is 150,000, the 300 is 300,000, and so forth. Again, to do the median, we have to first reorder them. We can tell that they're not in order originally because 150, 300, 350, then down to 232, up to 3, and so forth. So we need to reorder them in order. In this case, there are actually 8 values in the list and not just 7. So we have to take the 2 middle values and average them. So 300 plus the 350, sorry for the typo there, divide by 2, and we get 325. Over here, we're finding the mean, and we added them all up together, divide by 8, adding them all up, we got to 3,662, divide by 8, and our mean is 457.75. A note in this particular case that the mean is much higher than the median, and that has to do with the fact that we had an extreme value with that 1231. That will really change the mean compared to the median. All the values were different. There were no values repeated, so there was no mode. And in the mid-range, we have the lowest 150, the highest 1231, divided by 2, and we get 690.5. Now, by the way, this little fact here that the mean and median are so far apart shows you that in some circumstances it's better to use the mean for an average. In some situations it's better to use the median. So for example, when it comes to things like house prices, they'll often go with what's the median sale price, the middle value, because they don't want some house that's way out of what all the other values are. Notice how much bigger this one is than all the rest, to skew the middle value. They also don't want the opposite, which is they don't want some home that's been foreclosed on and therefore gone for very little to really drive down that average amount. And so they'd rather go with the mean being in the middle instead of taking the average. Here is an example of doing the mean for a frequency distribution. So again, we have our grades, 50s, 60s, 70s, 80s, and 90s. These are our frequencies. Here are our midpoints. So from 50 to 59, just a reminder, you add the 2, 50 and 59, that would give you 109, divide by 2, and you get 54.5. The midpoints are not halfway between the lower values, so it's not halfway between 50 and 60, it's halfway between 50 and 59. Then we set it up so that we can now do our sum. So 2 times the 54.5, 3 times the 64.5, and so forth. If you add up all the frequencies, you got to 20. So we come out with 1,530 over 20, or our average was 76.5. And so that's the way to do a mean of a frequency distribution. Now, this frequency distribution came from this set of numbers. What we're going to now do is compare the mean, knowing the actual data values, versus the mean where all we knew was what class those data values fell in. So for instance, we know that there were 2 in the 50s, 55 and 58 here, but in fact, when all you have is a frequency distribution, you don't know what the actual values are. Well, now we have them. And so let's see what happens. So we go ahead, add up all the different values. In this case, we ended up with 1,533 divided by the 20 for a mean of 76.65. And what I think is really interesting is just how close these two values are, despite the fact that a frequency distribution doesn't have all the details, doesn't have all the information that the original list would have had. So in one sense, it is better to have the individual numbers, but even if all you've got is a frequency distribution, which is a heck of a lot easier to look at than just a list of numbers, and this is only 20. Imagine if there's 100 numbers to look at. And yet, we got very, very close. If you were rounding to the nearest whole number, that would be 77. That would also be 77. You would have essentially the same amount. And so there you have it, measures of the center.